Hello viewers, so we're going to taking you through the story of A-level math paper 2. In this video, we're going to go through the marking guide for end of term 3 of math paper senior 5 for the year 2022. So this video is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So question 1 says, two events are such that probability of A is equal to 0.7, probability of B is 0.2, and probability of A given B is 0.1. Find Roman 1 probability of A union B and Roman 2 probability of A intersection B complement. So here they have not specified whether the events are independent or mutually exclusive or exhaustive, meaning that the only option is either to use set theory or contingency table. So you know that when I expand expanding this gives you probability of A intersection B divided by probability of B. But my aim is to get A intersection B, so when I make it the subject, I can be able to get A intersection B equal to probability of B multiplied by probability of A given B. I think realize that what is here is also similar to what is here. So for the product to be true, B, what is here should be the same as what is here. If this was probability of B given A, you could not multiply B with probability of B. So next we substitute for probability of B, which is that, and probability of A given B, which is that. You come up with probability of A intersection B. But that's not what they asked. It is going to help us to get the union. Because when I expand the union, there is probability of A, probability of B, and probability of A intersection B. So I come and substitute for A, substitute for B, and substitute for the intersection to come up with the output which they wanted. That was part A. Then for part B, they want probability of A intersection B complement. So that one you have to remember that A intersection B complement is the same as probability of A minus probability of A intersection B. So we have got this formula from the contingency table. Remember, the video for probability theory is available on this platform. So if you are still wondering where this came from, I encourage you to go and watch the video of probability theory and the playlist of probability and statistics. So next is substitute. Probability of A is 0.7 and A intersection B, you have already got it as 0.02. And with that we will get the answer as 0.68. So I think really the solution is brief, but all the marks will be got. 1 for this, 2 for this, and 2 for that. Then question 2 is under mechanics and it says a particle of weight 20 newtons is placed on a rough plane inclined at an angle of 40 degrees to the horizontal. The coefficient of friction between the plane and the particle is a quarter. When a horizontal force, note this word horizontal force, P is applied to the particle, it rests in equilibrium. Calculate the value of P. So math part 2, you have to first interpret the question correctly. Read through the question, underline the keywords, and so that you don't misinterpret the question. So here we have realized that the force is horizontal, because some students, they just draw a force which is parallel to the plane, which is not okay. 2, we have realized that the particle is in equilibrium. Okay. Then 3, you have realized that the plane is rough. And 4, we have been given weight instead of mass. So the common questions, they give mass, but this time they have given us weight. Okay, so what we need, we shall get our ruler and draw our force diagram, which will help us to resolve. So this is our inclined plane. The inclination is 40 degrees, and this is our mass. So we have to locate the forces. The first force is always the weight. Acts vertically downwards. Then you resolve the weight parallel to the plane and perpendicular to the plane. So we already talked about resolving on this platform. So if you are still wondering where this comes from, I encourage you to watch those videos before you watch this. That is weight. Next will be normal reaction. So the way you draw it matters. I think you realize that this line is perpendicular to the plane, and this line is horizontal, and this line is parallel to the plane. Another thing, you realize that this is dotted as well as this. So you should know which forces should be dotted and which should not be dotted. Then we shall put our horizontal force, which is P. And this force also has to be resolved parallel to the plane and perpendicular to the plane. Okay. But I've told us it is rough, meaning you have to first get the direction of motion, if to get the direction of friction, ask yourself, if the body is to move, where should it go? Should it go upwards or downwards? And that is shown by putting the arrows for acceleration. So if this body is released, it will move down the plane. So you put those arrows, but you should remember to put 0 because it is not yet moving. It is still in equilibrium. But this is to help us to know the direction of friction, because friction will always oppose motion. So because this is going downwards, friction will go upwards, and it is mu r. Okay, so you have put all the forces. Next is to resolve. So resolving perpendicular to the plane, r will be equal to these two. Okay, so what are the common mistakes? The common mistake, students here, they put G, 20G, and that makes everything not okay, because the weight was what was given was the weight. If this was mass, we would have put 20G, but because it was weight, putting here G makes everything wrong. Okay, then another common mistake is students are used to getting normal reaction equal to mg cos theta, but in this case it is not that. It has to be p sine 40 degrees plus 20 cos 40 degrees. Why? Because you have to resolve perpendicular to the plane. So don't overuse a lot of cram work. That is resolving perpendicular. What about parallel to the plane? Parallel to the plane, we have this being equal to this. Okay, now you have got two equations. The good thing, we have the equation of friction. So we shall come and substitute for the equation of friction and for r. And when you do that, we have only one unknown. Our aim is to make it the subject. So I'll come and simply open brackets here to come up with this. Then I will collect like terms. P on one side and take this on this side to come up with this. The next is to make P the subject. And that will be the answer they wanted. Then question 3 says a mobile phone dealer imports Nokia and Motorola phones. In a given consignment, 55% were Nokia and 45% were Motorola phones. The probability that a Nokia phone is defective is 4%. The probability that a Motorola phone is defective is 6%. A phone is picked at random from the consignment. Determine the probability that it is defective. And Roman 2, it is a Motorola given that it is defective. So yeah, the best approach is to use a tree diagram. So we shall have one branch will have Nokia phones, another one will have Motorola phones. Then on Nokia phones, there are some which are defective and some are not defective. Same applies to Motorola phones. There are some which are defective and some others which are not defective. So shall come and put the probabilities. They have told us that in a given consignment, 55% were Nokia. So this percentage is the probability for Nokia, and this is the one for Motorola. Okay, then in Nokia, we shall come here and say that the probability that a Nokia phone is defective is 4%. So this is the probability for defective under Nokia, and the complement will be 1 minus this probability, which is 0.96. Okay, then the probability that a Motorola phone is defective is 6%. So defective phone Motorola is 0.06, and this complement is 0.94. So tree diagrams were also available on this platform. Actually, a lot of content is available on this platform, content for math. That means that in this holiday, we shall concentrate more on physics, because physics we have so far covered very few compared to the syllabus. But if you do math, I encourage you to go to the playlist and watch those videos, because almost everything is available and very few is remaining to be covered. So Roman 1, the one defective. Defective, we have this and this. So that means that we have N intersection D, which is here, and M intersection D, which is there. Then we shall come and substitute N intersection D. We shall use this branch, which is here, and for Motorola we shall use this branch, which is we shall use this branch for defective, which is here. Then we shall use the calculator to come up with the answer they wanted. It is okay to give your answer in fraction form or in decimals. Then Roman 2, Motorola given it is defective. Given means it is now a conditional probability. So it will be M given defective. So the order matters. It is M given defective, M given D. Then we shall expand this one to give you intersection M intersection D over D. Then for the probability of M intersection D was got here, and it is this. So you don't need to recalculate, just come and substitute there. Then for defective, here it was already calculated as that. So come and put it there to give you 27 over 49. Like I said, it is okay to leave your answer in fraction form, or you proceed to get this decimal. Whatever you do, you will get all the marks. Then question 4 says, an elastic string of natural length 1.2 meter and modulus of elasticity 8 Newton is stretched until the extending force is 6 Newton. Find the extension and the work done. So this topic is under elasticity. We have to remember that the force in elasticity, force is equal to modulus of elasticity times extension over natural length. So you come and substitute. The force is 6 Newton, the modulus of elasticity is 8, the natural length is 1.2, so you can make x the subject. which will be the extension they wanted. They also wanted work done. So work done will be equal to, in elasticity, work done is lambda, which is modulus of elasticity, times x squared over 2L. Most students confuse it with the usual work done by a force, which is F times x. That is not okay when it comes to elasticity. Work done, we know it's force times distance, but when it comes to elasticity, the formula differs. Okay, so shall I substitute for modulus of elasticity, extension squared, 2 times original natural length, to give you that as the work done. That was question 4. Question 5 says 20% of the eggs supplied by a poultry farm have cracks on them. Okay. Determine the probability that a sample, this is a very vital keyword in this topic, a sample of 900 eggs supplied by the farm will have more than 200 eggs with cracks. So we have to first substitute. N is 900. P is the probability of success. Probability of success is got by, when you read the question, let's see how we got this 20. They say 20% of the eggs supplied in the poultry farm have cracks. So this 20% is for eggs with cracks. Okay. Now when you come to the question, they said determine the probability that a sample of 900 eggs supplied by the farm will have more than 200 eggs with cracks. So I think you realize cracks. That's how you can know that what was given here is the probability of success. And the probability of fail is the complement. So this shows you that it's under binomial, but you have to approximate because n is more than 20. So to approximate, we need the mean. Mean in binomial is np, so n times p to give you 180. Then you also need the standard deviation, which is root of np2, np and 2 to give you 12. So I've got mean, I've got standard deviation. Next is to use continuity correction. So continuity correction helps us to approximate, to change from binomial which is discrete to normal which is continuous. So this is what was given in the question, more than 200 eggs, x greater than 200. Then by continuity correction, it becomes x greater than 200.5. So it depends on how you are taught. Some students prefer to put greater than or equal to. It is okay because this is now continuous. But this putting here or equal to, it is not correct because this is discrete, this is continuous. Okay, now that you have changed to normal, we can now standardize. Standardize is to convert x to z. So this x to z gives you that x minus mean over standard deviation. Then when you use a calculator, what we get here must be rounded off to 3 decimal places. Remember, it must, some students, they used 4 decimal places here, which is never okay. Others rounded off to 2 decimal places, which is never okay. So a z value must be to 3 decimal places. And I already talked about that under the video of normal distribution. It is also available on this platform. So next is to get this value from the mathematical tables. So that one can be expanded as 0.5 minus phi of 1.705. Why? Because the table, the cumulative normal distribution table, does not have these values. It only has values from values of probability from 0 to a z value, which is represented by this phi. So we shall come here. How do we move from here up to here? There we need a mathematical table. So in A level it's allowed to go with your mathematical logbook in an exam. So we shall come in our table and look for 1.70. 1.7 is here. 0 is here. So read off this value, which is this. Remember it was 1.708. So the 8 is got in this add column, which is here. So it should be in the same line of 1.7, which is 7. That is why we come and add. Now, where are these ones coming from? We should remember that this one should be to 4 decimal places, just as this is. So when I add, I'll come up with this value, which is the probability I've got here. And after getting the probability, I can use the calculator to subtract and get the probability they wanted. Question 6 says, a pump with power output 147 watt can raise 7,200 kilograms of water per hour. Okay, through a height of 5 meters. Okay, and deliver it into a tank. Calculate the speed with which the water is delivered into the tank. So this power does two things. This power does two things. It raises water and also ejects it out. So the power which is used to raise the water is what we call potential energy per second. And the power used to eject the water out is what we call kinetic energy per second. So when you add those two, you'll get the power, total power. So you come and say here and say that mass per second is given by, remember, it was per hour, but our aim we need per second. So we have to convert to per second to give you 2 kilograms per second. Then from there you can code the formula that total power is equal to Ke per kinetic energy per second plus potential energy per second. Then you shall substitute. Power is that, M we have got as 2, V is what we want, M we got as 2, G is a constant, and H was given as 5. So my aim is to make V the subject, so I'll simplify and look for a way of making V the subject. And we take the positive value of V. That was question 6. Now we shall go to question 7. Boxes made in a factory have weights which are normally distributed with a mean of 4.5 kilograms and standard deviation of 2 kilograms. If a sample of 16 boxes is drawn, find the probability that the mean is between, so note this word, mean is between 4.6 and 4.7 kilograms. So mean, we put a bar here. I think realize here there is a bar, so don't forget that. So between, it means this mean is greater than this but less than that. Next is to standard. It is already a normal distribution, so our aim is to standardize. Standardizing because it was a sample, that is why we no longer use standard deviation in the denominator alone. It is now standard deviation divided by square root of the total number of the sample. The same applies to 4.7. Then from there we shall use the calculator. This one gives you 0.2 direct, and this gives you 0.4 direct. Now this is only one decimal place. Why is it so? It is because if you get your calculator and press, it gives an exact decimal which is less than 3 decimal places. If this value was, for example, 0.200201111 like that, we would round off to 3 decimal places. But this is an exact decimal. Okay, then next is to we want to read it from the table, but to read it from the table we have to use phi. So this one becomes, now how do you know whether you should add or subtract? You look at the signs here. This is positive, positive. Similar signs, subtract. Different signs, add. But for more explanations, they are there in the video for normal distribution. So let's read these values, 0.4 and 0.2. So still we shall go to our normal distribution table. 0.2 is this, 0.0793, and 0.4 is 0.1554. And those are the values we are seeing here. Then use the calculator to subtract and get the answer they wanted. Question 8 says a uniform ladder. Uniform, it is a keyword. Uniform means the weight acts at the center of the ladder. So a uniform ladder of weight 300 newtons and length 8 meters rests with one end on a smooth, this is also a keyword, smooth vertical wall, and the other end on a rough horizontal ground. The coefficient of friction between the ladder and the ground is 0.3. Okay, and the ladder makes an angle of 30 degrees with the ground. If a very heavy man of weight W climbs 0.69 meters along the ladder before the ladder just begins to slide, find the value of W. So note that the W is weight, it is not mass, it is weight. So we shall come and make a sketch first. So we have a vertical wall and a horizontal ground. Then we shall put the ladder lying on the vertical wall and the horizontal ground. Then the forces shall begin with the weight as usual, which acts vertically downwards and it's at the center because of the ladder is uniform. That's why you see that AC is a half of the total length. Then the man climbs 0.69 meters above. That means that AD is 0.69 and the weight is W. Then we have normal reaction here, and because it was rough there is also friction. For the wall it was smooth, meaning there is only normal reaction. Okay, so we have drawn the forces. Next is to take moments. So when I take moments and resolve. So if I resolve vertically, I'll come up with that. Vertically means this one is equal to these two which go downwards. What about horizontally? Horizontally, R2 is equal to 0.3 R1. But R1 is this, so I'll come and substitute for R1. So this is equal to this. Then taking moments about A, I'll come up with that. So remember the formula is FD sine theta. And clockwise are equal to anti-clockwise. When I take moments about this side point, these two are anti-clockwise and this one is clockwise. So these two will be equal to the moment of R2, as you can see it here. These two will equal the moment of R2. The next is to simplify. Substitute for R2. We have only W, which is an unknown, therefore our aim is to make it the subject. So I already covered the topic of moments, so you can go to the video and watch it. So when I make W the subject, I'll come up with that as the weight they wanted. So that was section A. Now we shall go to section B. Section B, you are supposed to answer 4 questions, but for revision purposes, we shall answer all in this paper. So question 9 says, The table below shows the marks obtained by 100 students in a mathematics test. Calculate the mean mark, then to draw a cumulative frequency curve and use it to find Roman 1 median and Roman 2 range of the middle 40%. So the first step here is to tabulate your values. So you come here and tabulate. So I already covered this topic of under descriptive statistics. You can go in the playlist and watch it. So shall I begin with marks. For marks, shall put these values here. But I think realize that these values have inequalities. So in our table, we shall not include the inequalities. We shall just remove them so that the marks due to the column is for both the class and the class boundary. Okay. The next is F. F means frequency. So these values here for number of students is our frequency. Those are the values shall put for each class. And then we sum up. We have to sum up all these ones to come up with the total here. Then we need X values. X is the mid mark or midpoint, which is got by this plus this over 2 to give you 30. This plus this over 2 to give you 45. This plus this over 2. 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 And this plus this over 2. Okay, now that I've got value column of X, F, and the column of X, we can get the column of Fx because they ask for mean. So Fx this times this gives you 150. This times this gives, 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 and this times this gives that. Then we need to add up all these values, and when we add up, we shall come up with a total which we shall put here. Because we are told to draw an ogive, we need a column of cumulative frequency. So cumulative frequency, keep on adding cumulatively the frequencies. First put this first one, then 5 plus 15, 20 plus 10, 30 plus 15, 45 plus 25, 70 plus 25, 95 plus 5. Okay, now we have generated our table. Next is to answer the questions that follow. So the first question, they ask for min mark. So min mark, we have to remember the formula, quote the formula, substitute, and get the answer, and that will be the mean. Then Roman part B, they want to draw a cumulative frequency curve and use it to find the median mark. So cumulative frequency, we plot upper class boundaries and cumulative frequency. So cumulative frequency against upper class boundaries. Therefore, we shall come here and get our graph paper. Here we need a graph paper. So we shall get our graph paper. When you get it, the first thing to do is to draw the axis using a long ruler. It must be a long ruler. Then get the scale for the horizontal. Label it. Also get the scale for the vertical. And label it. The next is to start plotting. Remember, like I said, plotting, we plot 40 goes with 5, 50 goes with 20, 55 goes with 30, 60 goes with 45, 70 goes with 70, 90 goes with 95, and 100 goes with 100. So let's plot those points. So the first one is 40, then 50, then 55, then 60, then 70, then 90, and lastly 100. Okay, after plotting, you have to draw a reasonably smooth curve through all the points, but not left hanging. It must go up to the origin. So let's do that. Okay, now that you have drawn, we can go ahead to the next part of the question. The next part says, use it to find the median mark. Median mark, you need to get the median position first. So shall come and say that from Roman 1, the median position is a half n. A half times the total, which is 100, to give you 50. That means that you will come here and locate where 50 is, then take a horizontal line to meet the curve. Then drop a vertical line to meet the horizontal axis. Read off that value, and that would be the median they wanted. Okay, that was Roman 1. Then Roman 2, the one, the range of the middle 40% of the marks. So nowadays, this is a common way of asking for percentiles. So range of the middle 40%, what does it mean? We already covered these middle percentages, so we shall not go through that. What we need to know is that middle 40% means 70th percentile minus 30th percentile. But to get more knowledge on these middle ranges, go and watch the video for descriptive statistics on this platform. So we need to get those positions of the 30th percentile and the 70th percentile. For the 30th percentile, it is 30. So shall come, we have to look for 30. And also for the 70th percentile, it is 70. So come and look for 30 here, take a horizontal line to meet the curve, then drop a vertical line to meet the horizontal axis. Then read off that value, and that will be your 30th percentile. Do the same for 70th, take a horizontal line to meet the curve, then drop a perpendicular to meet the horizontal axis and read off that value. After that, the range means you subtract. So I'll come and subtract and get the answer they wanted. Then question 10 says a random variable capital X has a normal distribution where P of X greater than 9 is this and P of X less than 11 is this. Find part A, the values of the mean and standard deviation, and part B, the probability of X greater than 10. So this standard normal distribution, it needs this standardization. So we shall first standardize from X to Z. Here we don't know the Z value, so we shall just put an unknown Z1 and maintain the probability. Then we shall sketch. Sketching helps us to identify whether the Z value will be positive or negative. So I'll come and put my Z1 here and shade greater than. I have put a negative because from here going this side is positive and this side is negative. So when Z is this side, it has to be a negative value. Now that means that we already know that the whole of this by symmetry from here going this side is 0.5. So what is left is the remainder when you subtract 0.5 from this. So I'll come and say that my remainder will be 0.9192 minus 0.5 to give you 0.4912. And that is what we read from our table. So we shall come and say that my 5 negative z1 is 0.4192. So here it was an error in subtraction. You can edit it. It should be 4192, not 4912. Okay. Then from there we shall get the z value from our table. So how did we get this 1.4? We shall come in our table, cumulative normal distribution. And if you look at this table, in the body there is 4192. The good thing it is exact, which corresponds to 1.40. That's where this one is coming from. But there's a negative, so making z1 the subject gives you a negative 1.4. Okay, so when I standardize, I'll come and say that 9 minus mean over standard deviation is equal to negative 1.4, and I'll get an equation. That equation will help us. We need to get two equations and solve them simultaneously. So we have dealt with this. Next is to deal with this. Let's do that in the next slide. So that one still standardize and then make a sketch. Put the z value, then shade. Then from there, remember that the whole of this is 0.5. So the balance is what is here. So the balance, we shall get it by saying this minus 0.5 to give you 0.258. Then shall come out here and say that 5z2 is equal to 0.258. Therefore, z2 is 0.7. So how was it got? It was here in our cumulative number distribution. 0.258 corresponds to 0.70. Then you can standardize 11 minus mean over standard deviation equals 0.7. Get equation 2. Then you have to solve them simultaneously. When I subtract, I'll come up with 2 equal to 2.1 times standard deviation. Therefore, standard deviation is that to 4 decimal places. Then from equation 1, actually this is not equation 1, this is equation 2. So here you change and put here equation 2. So from equation 2, 11 is here, mean is here, 0.7 is here, and standard deviation, we already got it. Therefore, I can make mean the subject, and that's what they wanted. For part B, says find the probability of x greater than 10. Now the good thing, we already know the mean and standard deviation, so we can easily standardize. So when you standardize, you shall come up with this. So to use the table, you have to convert it to phi, which is 0.5 plus phi 0.35. Then you can read it from the table. So reading it from the table, I'll come here and say that 0.3 is here and 5 is here, so the value is here, which is 0.1368, which is here. Then use the calculator to get this value which they wanted. So now we shall go to question 11. Question 11 says 5 forces of magnitude these ones act along the lines these ones respectively, meaning that 3 is for AB, 4 is for BC, 4 is for CD, 3 is for DA, and 5 is for AC. Of the square, so we are dealing with the square ABC of side 1 meter. The direction of forces is given by the order of the letters. Then taking AB and AD as the reference axes, Find Roman 1 the magnitude and direction of the resultant force, and Roman 2 the point where the line of action of the resultant force cuts a B. So the first thing to do is to make a sketch. Shall come and draw a square, then shall put the forces. AB corresponds to 3, so come and put it there. BC corresponds to 4. Then CD corresponds to 4. DA corresponds to 3. And AC corresponds to 5. Because it's a square, this angle will always be 45 degrees. Then next is to resolve. Resolving this is 30, this is 04, this is negative 40, this is 0, negative 3, and this is 5 cos 45, 5 sin 45. So already on this platform there is already a video for composition and resolution of forces. You can watch it to know how to resolve. So when I use a calculator, I'll come up with this. It is okay to give you answer in side form, but this is better because it is less confusing. But they ask for magnitude and direction. So magnitude is got by this squared plus this squared over under square root to give you that. What about the direction? The direction shall first draw a right angle triangle for positive horizontal and negative vertical. Then from start, a line joining from start to end is our resultant. So our theta is the direction they want. So we shall come and say that tan theta is equal to opposite over adjacent to give you theta as 60.79. Then you can conclude the magnitude is this in the direction this with a B upward. Or you can say above a B. Then for part B, they say the point where the line of action of the resultant force cuts the side AB. That means we have to first get the equation of the line of action. And get the equation, you have to take moments. So G is anticlockwise, sum of anticlockwise moments about the origin, which is A. Then the equation of the line of action, all these ones are available on this platform. So this is the equation of the line of action. Then you can substitute for G, which is here. Then X is left. Then summation of Fy is the vertical component of the resultant force. Summation Fx is the horizontal component of the resultant force. That is our equation. Then we shall come and say that at the point where the line of action cuts AB, y is equal to 0. In other words, they want an x-intercept. And when y is 0, come and substitute here, the whole of this becomes 0, and then I can make x the subject. And that's the distance they wanted. Question 12 says the heights x in centimeters and edges y in years of a random sample of 10 farmers are given in the table below. Part A, Roman 1, calculate the rank correlation coefficient. So in A level, it is only one correlation coefficient which is still on the syllabus. Because product moment is no longer on syllabus, candles is no longer on syllabus. So even if they don't specify, always know that they want you to calculate Spearman's rank correlation coefficient. The Roman 2, comment on your result. Part B, plot a scatter diagram for the data and hence draw a line of best fit. Part C, use the diagram in B to find Roman 1 y when x is 147, and Roman 2 x when y is 43. So let's start with part A. To draw to calculate the Spearman's rank correlation coefficient, we need to tabulate some values. So let's go ahead and tabulate. So x shall put the values for height. And the total of all those ones is this. We put the total because they told us to draw a line of best fit. If they didn't tell us to draw the line of best fit, then there's no need to get this total. But now that they told us to draw it, we need that total. It will help us somewhere. Then y, we put the values for the edges. Then you also get the total of all these values and put it here. Okay, now next is to rank. Ranking is done in descending order. The biggest value gets the smallest rank. So here in the values of x, we shall look for the biggest. It is 160. So it gets rank 1. Then next 150, it gets rank 2. Next 57 gets rank 3. Next 56 gets rank 4. 52 gets rank 5. 51 gets rank 6. 149 gets rank 7. 146 gets rank 8. 142 gets rank 9. And lastly 140 gets rank 10. So ranking is in descending order. What about the values of y? So we shall do the same. Descending order, the biggest is 55 gets rank 1. 49 gets rank 2. 47 gets rank 3. 46 gets rank 4. 45, now there are two 45s. One would have got rank 5. Another would have got rank 6. So what we do, we have to give them the same rank, meaning we have to get the average. So we shall come and get the average of 5 and 6, which is 5.5. And that's what we shall put for both. So this will get 5.5 and this one also 5.5. Now 6 has been taken. I think you see it here, 6. Now next rank will be 7. So this value will get rank 7. And this will get rank 8. Now these are also two. One would have taken rank 9, another one rank 10. But because we have this, they should have the same rank, we have to get the average of 9 and 10, which is 9.5. So both we shall put here 9.5 and here 9.5. Okay, now that we have got the ranks, we shall go ahead and get the corresponding differences. This minus this, this minus this, subtract, 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 subtract. Then we need the squares of these differences. So this squared for this squared, this squared, 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 squared. Okay, then we need to get the total of all these ones. So total will be 41. That total is what will help us to calculate our Spearman's rank correlation coefficient. So quote the formula, substitute. N is the number of pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why you see here 10. Then use the calculator. And after that we have to comment. Commenting and say significant at 5% or insignificant at 1%. Why do we say such a comment? It is because of the table. So shall come at the table. We have 10, which is there. So we have these two values. There is this for 5% and this for 1%. Okay, so if you look at your values here, calculated value is 0.7515. 0.75 is bigger than the 0.65, meaning at 5% it is significant because of what they said here. They said significant if what is calculated, the magnitude of what you have calculated exceeds what is in the table. So significant at 5%, but at 1%, 0.75 is smaller than 0.79, so it is insignificant. That was part A. Now we shall go to part B. Part B, plot a scalar diagram for the data and hence draw a line of best fit. So we shall need a mean point. Mean of x, mean value of x, mean value of y, and the mean point is that. Then from there you can now get our graph paper and start plotting. Draw the horizontal axis using a long ruler and the vertical axis using a long ruler. Get a horizontal scale. And label the horizontal axis. Do the same for the vertical. Get the scale and label the vertical axis. The next is to plot. Plotting, we are plotting x, we are plotting coordinate by coordinate. This one, so 156 corresponds to 47, so shall come and put that point there. 151 corresponds to 38, put the value there. 152 corresponds to 44, put the value there. 160 corresponds to 55, put the value there. 146 corresponds to 46, put the value there. 157 corresponds to 49, put it there. 149 corresponds to 45, put it there. 142 corresponds to 30, put it there. 158 corresponds to 45, put it there. And lastly, 140 corresponds to 30, put it there. Okay, now we also have to get to plot the value of the mean point. Mean point 151 corresponds 151.1 corresponds to 42.9. So I'll come and put it there. The next is to draw a line of best fit. The line of best fit must fulfill three conditions. One, it must pass through the mean point, which is this. That is 1. 2, it must pass through any other points plotted. And 3, it must leave equal or almost equal points on either side. So if I fulfill those conditions, I'll draw my line of best fit as that. So let's see if it fulfills. 1, it passes through the mean point. That is the first condition. 2, it must pass through any other one or more points plotted. So it has that, it passes through that. So the second condition is fulfilled. 3, it must leave equal or almost equal points on either side. So this is side 1, 2, 3, 4. So here there are 4 points left. What about this side? 1, 2, 3, 4. So 4 points. So all the 3 conditions have been fulfilled, meaning the line of best fit is okay. Next is to go to part C, Roman 1, find y when x is 147, and Roman 2, find x when y is 43. So let's start with Roman 1. When x is 147, what is y? So it is okay to draw any other line of base fit provided it fulfills those three conditions. So when y is 147, come and take a vertical line up at 147 to meet the line of base fit, then take a horizontal line to meet the vertical axis and read off that value. And that will be the value of y. Then Roman 2, do the same. Look for 43, take a horizontal line to meet the line of base fit, take a vertical line down to meet the horizontal axis and read off that value. And that will be the value of y. Basically, that's what they wanted in this question. Then question 13 says, two bodies A and B of masses 3 kg and 2 kg respectively are 7 meters apart on a smooth horizontal surface. A is moving directly towards B with a speed of 2 meters per second and an acceleration of 0.3 meters per second squared. B is moving in the same direction as A with a speed of 5 meters per second and a retardation of, now this is the retardation, 0.2. If the bodies collide and coalesce, calculate Roman 1 the time taken before collision occurs, and Roman 2 the common velocity immediately after collision. So let's start with part A. Let B be the distance. Let B move a distance x before collision. That means that for body A, using the second equation of motion, the distance moved will be 7 meters more because it was 7 meters apart. So x plus 7 here is our s. Then u is 2. If you look at this, then acceleration is 0.3. Okay, to give you that as equation 1. Then for body B, using the second equation still, distance is x, which you already let here. Then the u is 5. And retardation means negative this. That is why you are seeing a minus here. So that gives you equation 2. So there are 2 equations and 2 unknowns. We have to solve them simultaneously. So substituting equation 2 into equation 1 gives that. Then simplify to get a quadratic, solve the quadratic and get the output. Then eliminate 1 and remain with the positive time. So here this should be a negative here. That was Roman 1. That was part A. What about part B? Part B says the common velocity immediately after collision. Now, because there is acceleration and retardation, it means the speed, the velocity keeps on changing. So we have to get the new velocity at the point of collision. So for body A, the velocity at the point of collision is 6.2, and for body B, the velocity at the point of collision is 2.2. And those are the ones we use when we are conserving momentum. Initial momentum is equal to final momentum, or momentum before is equal to momentum after collision. Then you substitute and make V the subject. And that's what they wanted. Then for question 14, a continuous random variable x has a cumulative distribution function given by this is capital F. Determine the value of k and hence sketch the graph of capital Fx. Then part B, find the probability density function of x and hence find the probability of x between 1 and 2. So one, you should realize, take note of these words, hence. Hence, they mean a lot. So let's start. As long as it is capital Fx, it means you no longer integrate. What you do is substitute. So come and substitute. When x is 3, I'll come and substitute it here. Here, where there is x, you put 3 to come up and equal it to 1, because this 3 is in both these two parts. That means that k is the only unknown, make it the subject, and that's what they wanted. Then you can rewrite our capital Fx with k substituted. Then they said sketch the graph. So for the hence part, f2, because first of all, f0 we already know it is 0. Then f3 we already know it is 1. But f2 we don't know it, so we have to come and substitute and get 2 over 3. So now that we know the value of fx when x is 2, we can now come and sketch. So we need the two axes, horizontal and vertical. So when x is 0, fx is 0. And when x is 2, fx is 2 over 3. So come and draw that curve for this interval. For that interval, it is in this form. I think we note the shape of the curve. Some students use a ruler. When you use a ruler, it is not okay, because a ruler is used if there is no power on x. That is 1. 2, you can't draw such because the coefficient of x squared is positive. If it was negative, it would be in this form. Just as you're going to see in this next branch. If you look at this next part, the coefficient of x squared is negative. Therefore, our shape will be in this form. Hope now you know the difference. When this is negative, it is in this form. When this is positive, it is in this form. Okay. Then at 1, x greater than 3, it is 1. We don't know where it ends, so we shall come and put an end with an arrow. So this arrow is very vital. It means that it is continuing. You don't know where it will stop. And that's what they wanted. Then for part B, they wanted to get the PDF and after that to get this probit using that PDF. So to change from capital Fx to small fx, you differentiate. So differentiate that part, differentiate that function also, and also differentiate 1. Then you can write your small fx. After that, you can get the hence part. For the hence part means you use fx, meaning you have to integrate, and that would be the answer they wanted. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on subsidiary mathematics, end of term 3. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that you can all benefit as a family.